Hello and welcome to the Serverless London Meetup. I'm really glad you can join us today. And we have two great speakers. We have Matt talking about QLDB and Yann from Koyeb speaking about Firecracker. So we can have some really interesting talks. Matt's going to speak first about QLDB. Before we kick off, I'd just like to say thanks to our sponsors, Theodo and Senzo, and thanks to the other co-organizers, Alex White and Ant Stanley. And if you have any questions, feel free to drop them on the YouTube chat. I'll be able to see them here. And at the end of each of the sessions, we'll run a quick Q&A session. So drop your questions throughout the talk and we'll bring them through at the end. And if at the end of the talk you have any others, feel free to add them on. Without further ado, let's kick off with the first talk. So we have Matt Lewis, Chief Architect at the DVLA, speaking about QLDB. Hey, Matt, how are you?
Hi, Ben. Yeah, I'm good. Yourself?
Yes, not too bad. Okay, I'm going to add your talk to the stream and I'm going to drop off and let you take it from here.
Okay, thanks. So welcome, everyone. My name is Matt Lewis. I got the privilege of being an AWS Data Hero. So alongside getting the opportunity to play around with a number of the AWS data services, I'm also a big advocate of serverless technology. So I'm one of the organizers of ServerlessDays Cardiff, just down the road from London in South Wales. So this is why I always like, jump at any opportunity to combine these sort of two interests. So hence this talk looking at building trust at the data layer with serverless. So we start off with the data layer itself and looking at database engines within AWS. And what we find is that there's this whole family of purpose-built databases. And, you can go back to a blog post by Werner, going back a number of years now, where he talks about a one-size-fits-all database doesn't fit anyone. So now within AWS, you have this broad portfolio of different database engines, depending upon your use case. So it allows you to pick the right tool for the job, whether that's a more traditional relational database, whether that's MySQL, Postgres, a commercial Oracle, SQL Server, Aurora, and so on. Or if you're looking at more the key value, document in memory, and so on. But when we talk about trust, in terms of building or choosing a database engine that's right, that fits your use case, one of the first ones I look at when it comes to trust in the data would be what's badged as a ledger database. And for AWS, that's Amazon Quantum Ledger Database, or QLDB. So imagine there's a number of people who may not have come across the term of a ledger database and a little bit unsure of what it is. So this is trying to give a little bit of positioning. So the concept of a ledger is something that's not new, and you can actually trace it back many centuries, sort of 14th, 15th century with accounting. So there, what happens is you record a transaction first in the journal, and that was known as the bucket primary entry, and that was recorded in chronological order. And then you'd record it then, so you transfer that data then into the ledger, which is the bucket second entry, and that's what became known as this double entry bookkeeping. And what that gave you is that full audit trail. And that's what you get with QLDB, where it's a journal-first architecture. So the journal is a first-class citizen. And this concept of a journal is nothing new when it comes to sort of modern database systems. So often they'll be referred to as something like a transaction log or a write-ahead log or a redo log. And in those systems, effectively data gets written to these journal files, and it gets committed there before it gets written to the data files where the tables reside. The reason behind that being that if there's a system failure, you'll be able to use that journal to recover data. Where it's different with QLDB is that the journal is a first-class citizen, so no data can be updated without going through the journal first, and it only contains committed transactions, so you don't have to worry about rollbacks. So as the transaction is committed, the padlock signs are supposed to give an indication of an aspect of security or cryptography. So when you commit a block of data to the journal, a SHA-256 hash is created for that block of data. So that's a one-way hash function. So from the document or the record that you're looking to commit, it generates this hash. And this hash is a fixed length signature. And from that hash, you're not able to go back to discover what the original data was. But each time you'd be able to, that same data would always recreate that same fixed length signature. And then it uses this concept of hash chaining. So the journal is append only. So as you append the next block to the journal, it calculates the hash for that block of data and it chains it with the previously committed hash. And then it starts building a Merkle tree above the journal. And that's then used for some of the verification, which we'll come on to later. So the QLDB service then projects that data into your user-defined tables that you can create, and it provides a number of views on these tables. So you have the current state view if you just select some data from a table, and that returns what you'd expect, which is just the latest version of a particular record. It then also has this committed view. And the thing with the committed view is it actually adds this system-generated metadata. So it records things like the transaction date and time, generates a unique ID, it specifies the block address within the journal. And there's also a function, which is the history function. And what the history function allows you to do is go and query the history, and that allows you to view every single revision that has been made to that particular record. So in that case, you never actually overwrite data, you simply append data, you record every single revision. And then there's a whole bunch of capabilities that we sort of show, some of them on the right-hand side. So at any point in time, you can export all the blocks of data in the journal. And that gets exported to a bucket in S3. And from there, you can do some audit, you can do some analytics on top of that. Because what you realize is that that block of data that gets committed doesn't just contain the record itself, but it also contains the statements that were executed to cause that change. So QLDB uses something called Particle, which is a SQL-like query language, which we'll see later. So essentially, it shows you all of these SQL statements along with the data that's been revised. A release that came out last year was QLDB Streams. So QLDB Streams allows you to connect a ledger up with a Kinesis data stream. And this has now seen more and more popularity around event-driven. So what QLDB Streams allows you to do is to stream out in near real time all changes, all state changes that have been made to a journal. And that then allows downstream consumers to build, to respond to that particular event, whether that's to build another purpose-built database for analytics, whether it's to respond. So something's being created and you want to print and dispatch something out. So it really supports this event-driven architecture. And finally, you have the verification, and that then starts using this Merkle tree. So you can generate a digest for a journal, and that represents the tip of the journal and all the history of document revisions as a hash. And you can then select a particular revision of a document, and you can use this cryptographic verification to prove that that record exists at the same point in the journal as when it was committed, and that no data has been changed. So I was going to, the plan is to show an example of the verification towards the end. It may seem a little bit out of context, but I kind of figure that what I'll do before then is show examples of what we mean by sort of block address and where that data is, and give examples of the digest. So hopefully mean a little bit more by showing it later. So these then are some other key features of QLDB. So the first is that it's fully serverless. And by that, it means that when you create a ledger using QLDB, you don't need to specify EC2 instance family types, auto-scaling groups, anything. All of the underlying infrastructure is managed and scaled for you by AWS. So that's a big bonus. Talk about being secure by default. What I mean by that is, for those of you that may spin up things like an RDS cluster, you'll get an admin user created with a username and password, and then it's your responsibility to go and lock down and secure that cluster in whatever way that you need to. So with QLDB, you can't log on to the QLDB service. There is no concept of that. And again, it just reinforces the security aspect and how you can then enforce sort of trust and gain confidence in the data. And probably the most important one for me is data that gets committed in QLDB is immutable. I tried to touch on, we'll show more examples in terms of when you write data, you're continually appending. So the journal is append only. What that means is you're constantly capturing all the revisions to that data, and that data itself is immutable. QLDB is schemaless. So when you create a table, you don't define a rigid schema. It's schema on read. So if you need to enforce something, you can select that data and then you can apply any change to that. But what that means is that you don't need to worry about doing any of this sort of data manipulation. You don't need to worry about adding columns or changing anything to the schema. It's completely schemaless. It also uses IAM for authentication authorization. So again, you don't worry about username and password. And this is where, for me, it fits in really well with serverless. So if you're using things like a Lambda function to interact with QLDB, then you just need to make sure that your execution role has the right permissions to be able to execute those commands. And then finally, the concept of the QLDB driver and all of these, the challenges that it abstracts away from you. So the QLDB driver handles everything in terms of the transactionality. So it provides this serializable isolation level. So it provides full atomic transaction support. It handles all the session management, and it also handles all the connection pooling. So, I think one of the common complaints that originally came out was, how do you mix up a sort of a serverless and a servered world? And one of those challenges was with some of the more traditional databases. And that's where we're seeing with RDS, that AWS releasing services like RDS Proxy to try and make it easier to sort of interact with it when you're using something like a Lambda function, that you could get a large number of concurrent executions come in that spin up all of these Lambda functions that then go and create connections. So the QLDB driver abstracts away the connection pooling from you, and that makes it a really good fit for serverless. And the reality is that not all data is created equal. So you can think of some examples. If you take social media, you can create a post and submit it, and then with distributed services and eventual consistency, what you may find is that you don't see your post, you submit it again, and all of a sudden you see a duplication. But is that an issue? The reality is it's not. You can take a lot of some of the work with IoT data, where you're trying to gather data from all these sensors. You may be generating a forecast, and if some of these endpoints aren't available, then you can simply extrapolate it out. And the fact that one or two endpoints are missing from it tends to not be an issue. But if you go online and you check your bank balance and it's wrong, that then becomes an issue. So there are certain types of data that is more critical and more important than others, and you have to have confidence that it's correct. So these are things where you need to be able to prove what the state of a record was at any point in time. And one of the interesting stories for me was that QLDB itself wasn't a new service that AWS built from customer demand. They actually built it from an internal requirement that AWS had. So they had this need that they wanted to record in a searchable and an immutable transaction log that recorded all data plane changes. So that meant that if they had a degradation in service, if there was an outage, they'd be able to go back and they'd be able to check exactly what the configuration was of a service or a combination of different services to try and understand why that may have taken place. And this is something that they then built out to be the QLDB service as we know it today. So actually, the internal service that is based on has been tried and tested at scale and underpins a huge number of AWS services. So if you go in and spin up an EC2 instance, if you go in and put a message on a Kinesis stream, if you scale up or you create an auto-scaling group, all of that interacts with the QLDB technology internally within AWS. So it forms the backbone of the QLDB product. So we start thinking about these use cases where trust in data is important. And we touched on this, being able to view the state of a record at any time. And obviously, something like that is possible in a number of different database engines. So this is actually a recent blog post. It's a couple of months ago, published by AWS. And they talked about this requirement to use time-based or version number-based version control within DynamoDB. So they gave an example where maybe that there's a factory, it has some equipment, the equipment's made up of parts, and how might, if you've got this requirement to record the state of a part at all points in time, how might you model that in DynamoDB? And this shows an example where you have an equipment item collection, and then you start using sort keys with a metadata sort key, and then this sort of incrementing version number sort key. But there's a lot of things that you have to do yourself. So I thought one of the interesting things is, where people have this use case about trying to retain state, trying to look back and track changes in state. Well, how might you do a use case like that? And how might you implement that in QLDB? So if I jump across into a terminal window, so QLDB provides something called the QLDB shell. So it's basically an interactive shell that allows you to execute these sort of particle statements. So I created a ledger called Serverless London. So I can log into that ledger. Now, if I want to go in and create a table, hopefully you can start seeing the familiarity of the syntax. I can just go in and create a table called equipment. You can do things like, if you want to, you can go in and create indexes on it. So say I want to create an attribute called ID and I want that to be searchable in index. So you can do that. And now I can start inserting records. So I can sort of insert in, I'm trying to think exactly. So say we want to have an ID, we'll call it 123. And I think there was something like a status in the last slide. So the status could be ready. It's a fictional example. So here that we've inserted data. So it's inserted a document into that table. We create an index on the ID. And what you can then go and you can kind of say, we want to update the equipment table and we want to set status and we'll set it equal to, I think there was one that said like warning. So we do like update equipment set status equals warning with the IDs 123. And the document ID gets returned as a unique ID for that document. So we'll come on to that later. So when we talk about these different views that then get generated, what we can go in and we can say, just do a very simple, like select everything from equipment, where the ID equals 123. And that returns the latest record, and it's a JSON document. It's actually Amazon Iron, which is a sort of like a superset. But that returns a JSON document showing the data that we want. So that's exactly what we sort of expect. It also has this committed view that I talked about. So if you want to query the committed view, we can query the committed view of equipment. Again, where the ID equals 123. Staff and unstore committed equipment. Try that again. The challenge is being a live demo. Okay, we'll come on to that later, and I'll try and fix that. Let me just check to see if I've actually spelled committed right or something. So just one T. No. But then the other things that we can then do is query the history function. So we can use the history function querying equipment. Oh, actually, so let's say it was an intentional error. When I started talking about the committed view, what the committed view, it adds this system-generated metadata. So what you actually start seeing is that your data is returned in an envelope of data. So when we query it, you'll actually see that this is the committed data. So this is the data that gets committed into the block. And you'll actually see that you see the block address. So there's a single strand in QLDB. So we see that this block is number 69 in that strand. We'll see the hash, which is that SHA-256 hash that's been generated. We'll see the data that have been committed. And then we'll also then see the system-generated metadata. So the unique document ID, the version number, the transaction time. So if I then want to go and query the history function, so select everything from history. Now this is what we'll end up doing now is we use the unique document ID for this. I get this right, so it's a metadata.id. When we query the history, what we see here is that we see both revisions. So version 0, it's a incrementing version number starting at 0. So that was the very first time that we created a record, and we can see that that was the status of it, ID 123, status ready, and then we can see version 1. And when we talk about it being schemaless, that means that, we can update equipment, we can set a new value. Let's say we set an attribute called quantity, and we set that equal to 100, ID equals 123. So now if we want to go back and we sort of go and go from equipment, we've now basically added a new version of that record and added a new attribute without having to worry about changing schemas. So it's incredibly powerful. And one of the things that it reminds me of is another use case around something like event sourcing. So I'm not sure how many people are familiar with event sourcing. I put a quote there from Martin Fowler around, with event sourcing, you basically record all changes to application state. You record them as a series of events. And what that then means is if you want to understand a state for a record, you build up or you hydrate the history from all of those events to get to the current state for record. But you can also go back and you can reconstruct the state for record at any point in time, which then proves to be really valuable. And there's another quote here from Martin Kleppmann, who's the author of a brilliant book called Designing Data-Intensive Applications. And again, he touches on things like event sourcing, but he also notices that, if you're going in and you're overwriting a data item, that's a destructive state change. That's your mutating state. And you end up losing this historic information. So if you ever have this requirement to go back and say, well, what was the state of that attribute? With things like QLDB, you don't have to worry about trying to plan in advance and say, well, how do I want to model this data? You know that you record every single revision of that document, and you get that for free. It's all this undifferentiated heavy lifting. Alongside that, the QLDB streams then fit in really well. So one of the things that we've done is built out a live QLDB demo. So this is something that everyone can access if they want to do a show not tell and they want to try it out for themselves. And it really also shows how QLDB fits in really well with a whole bunch of other serverless technologies. Kind of ignore a little bit Elasticsearch at the top. So this demo, basically, we built it out, and I'll show you it. And the source code is available if you want to then clone it and run it in your own account. So the web UI, it's a React UI that's built using Amplify framework, deployed in S3. It's got a CloudFront distribution in front of it. We also used Cognito to sort of authenticate the users. We have the Amazon API gateway that acts as this sort of gatekeeper. We're trying to think about security as well as something that's a first-class citizen. So as part of the demo, we assign a WAF ACL to restrict IP limits to the rate limits of it, and we also use Cognito User Pool as an authorizer for API gateway. So it basically means that only authorized users can access the service. And then we have these services. It's a bicycle license domain. You can go and create a bicycle license, update it, make all of these types of changes, add points, remove points. The identity comes through as a claim, and we extract out the unique ID based from that Cognito user pool. And we use that just to make sure that when you actually query it, even though it's just a prototype, you're not able to see anyone else's records. And we use Kinesis then to stream that out, and we have two different Lambda consumers. One writes it to Elasticsearch, one writes it to DynamoDB. So let's just go and have a look and see this demo now. So again, this is like the Cognito hosted UI. So got a user that I've created in here, so we can come in. This is our sort of register service. So it uses Faker just to generate some fake data. We've got the history service, which uses the history function. The search service is Elasticsearch, nothing there. And then we've got the inquiry service. That queries DynamoDB, and that basically says, I don't have any licenses that I've created. So we can go back to the register. What I'll end up doing is just put my surname in, create the data. This goes off. This is the data that gets returned from it. What I can do is I can go and update, add 3 penalty points. Update again, it's got 6 penalty points. You can take penalty points off. We can also go through and change the contact details. And then at any point in time, if I click on latest, this shows the history version. And I sort of see this view as being very similar to what you might see in your sort of bank statement. So now we see the event, so what the change was, and we can go and click through and look at any of these sort of revision details. So this shows then how we can build this up. And what I can do now is go into search. So in real time, fingers crossed in real time, that has gone across, and that'll be streamed into Elasticsearch, and here we see it in Elasticsearch. We can go and click on the inquiry, and we can go and see that, here's this information that's now in DynamoDB. I can click in. I can go and amend it if I want to, and things that I can do, I can go in and delete that license. Click on latest, and now we can see that the license is deemed deleted. And with that license deleted, what that means is that if we look in the current view, that record does not exist. If you select it from that current state, it's not there. But because the data is immutable, it is still there in the journal, and when we query the history view, we're able to capture that event and show that that license has now been deleted. And then the final one is around cryptographic verification, just to give you an indication of how that works. And for that, I was going to sort of jump into the console. So I touched on very briefly, because the verification is something that you don't find with any of the sort of AWS database service. At any point in time, you can generate a digest, and that basically builds up all of these hashes in this Merkle tree, and it's the root or the tip of your ledger. So it represents the history of all document revisions at that point in time. So this is like an example digest that gets generated. It's the hash, the tip address showing the sequence number, what the ledger name is, and the date or the timestamp that it was generated. You can then query for a particular revision, and you can ask for a proof, and that then returns all of these hash values. And then essentially what happens is you're responsible then for calculating these hash values, chaining them together until eventually you come up with and you calculate what you believe the digest should be. And you can compare the calculated digest with the value that's in the digest. So if we jump back to the console now, so I can go, here's the Serverless London Ledger. I can go and get the digest for that. That has come in, and I'll save that out. So then now when I come in, if I want to verify a document, I can choose the ledger. I need to choose the document ID and the block address. So if I go back in here, well, let's just take this one. So we'll take this document ID. Take this block address. Choose the digest, one we just downloaded. Let's see what I did. Let's just try and generate the digest again. Well, let's see if this works. Again, the demo curse. Choose the digest, and then we can click on verifying. This comes through, you see, so here's the hash that was from the original revisions, the original document. There's a whole set of proof hashes that have been returned. So it calculates all of these to come up with a calculated digest. It compares the two. And by doing that, it then sees that the calculated digest matches the original digest. So that has now shown that that revision of that document is in exactly the same point in the journal as when it was first committed, and no data has been changed. So again, all of these things being really powerful when you want to try and prove trust at the data layer. So with that, thank you very much for inviting me to talk, and we'll go back to Ben.
Hey, Matt, thank you so much. It was a really great talk and really great to see the hands-on demo. I'm just seeing if you've got any questions come through. I'm not seeing any in the chat right now. I think we may have one that's just gone through. I'm just going to display that on the screen. So any big ORMs supporting this yet? How would you migrate from a live traditional relational database management service?
So actually, no, there's no ORMs that I'm aware of. It's one of those interesting ones. So playing around with it, when it was in preview originally, so the first driver that came out was the Java driver, and it was actually a JDBC driver, and we were looking at using that with an ORM with Spring. And then the QLDB driver that got released wasn't JDBC compatible. So it doesn't support any ORMs at the moment, and I'm not actually sure if that is anything that will be supported going forward. In terms of migrating, I guess part of that is just how you want to store or migrate that data into it, in terms of whether you sort of roll out and start from an initial point. So is there a requirement to retain that historic data? In which case you may want to just keep, if it's in something that's managed with like Aurora and RDS, you could take a snapshot that you could always restore if you wanted to query that. You could, do an extract, export it into S3, and you could always run things like Athena on top if you did want to query some of that data. So some of it depends upon whether you need to retain that historic data or not. I mean, the thing that I sort of see really valuable with it is, a lot of the times, especially if you're in an organization or in an industry that's quite heavily regulated. So you talk about things like, some of the stuff in government, healthcare, finance, and so on. You often have this requirement around the sort of audit trail. And I frequently see that being written into the application layer. And then you've always got this danger of, what happens if someone goes in and just, you try and make a database immutable, or you have that concept, and then you suddenly realize that actually there's something wrong. We've done a data load, or we've imported some data and it's actually slightly invalid. And then the number of times then, it's common because we want to fix this as quickly as possible. A DBA could go in and simply we're just going to amend these records. But then by amending it, what you're simply doing is overwriting data, because at that point in time, that was the state of the record in the production database. So the thing that's really nice, when we've looked at things like event sourcing, we found some issues with it, or, some of it in terms of how people found it. But what we really valued was the immutable data. So this gives you a way that you can go in and you can do, you can mutate data in terms of doing an update, but you still have that audit trail. You can still go back and see. So, in terms of the migration, in terms of how you might migrate, I think some of it for me is just in terms of how much of that historic data do you need to bring across. I definitely keep a snapshot that you could query in case you need it. And then, like I say, effectively, you just be writing that data, and that would be your starting point.
Awesome. And I think you covered some of the aspects of the question actually from Yann, which is, what are the main use cases for QLDB that you've seen in production?
I think a lot of it is coming down to, when it becomes critical to prove the state of a record at a point in time. So there's use cases that they have. I think there's one which is like coffee beans or something. We see a lot where it's some of the stuff in terms of, BMW are big users. Some of that is around their supply chain. When Werner first announced it, I think it was reinvented about 2018, and then it was in. It didn't come out for preview for a good while, and then didn't go into GA for about another year or so. They were talking about effectively the DMV in the States, but part of that was it wasn't just the immutability of the data. It's things what we talk about with this sort of audit trail, that, a lot of the time you may be an organization that, you may need to prove beyond reasonable doubt that this was the state of the record and that it couldn't have been altered in another way. So, there are quite a few examples coming out now from things like healthcare, insurance, something where someone's made a claim. You want to understand, well, when did that, when did you take out insurance? What was the exact transaction start? Could it be, could someone have amended that record? So this not only has the concept of the immutability, but you have the cryptographic verification aspect that's been built on top of it.
Sure. And then one final question is, does QLDB support ACID transactions?
It's fully ACID compliant, and it actually offers, when you look at things like, so basically you have an execute Lambda. I'm more familiar with effectively the JavaScript library. So it's provided in TypeScript. I tend to use plain JavaScript. So I use like Node.js for the Lambda functions. So there's an execute Lambda function. And what that then does is that all executes within an atomic transaction, and the QLDB driver handles the retries. So essentially what that then does is when you query the record, what the driver will end up doing is it will go and check to see, because it handles, you saw hopefully in the committed view that there's things like transaction start date times, that knows when a particular record has been changed. So what the execute Lambda does is start a transaction. Even if you're just reading data, it starts a transaction. And then when you go to commit it, the QLDB driver checks to see if that record has changed between when you started and when you're looking to commit. And if it does, then you can configure retry limits. So it'll configure up to, you can specify how many times you want it to retry. If you don't retry, it will throw what's called an OCC, so an optimistic concurrency control exception, back to the client, and they handle it. Otherwise, it will retry. But yeah, it's fully ACID compliant. Actually, I can put a link up after when I dig it out. So I did a blog post around this only about a couple of weeks ago, looking at it both from being ACID compliant, so how it handles the atomic, the consistency, the isolated durable, and so on, but also digging more into the isolation level as well. Because like I say, it's fully serializable, which normally is an impact on performance, but the journal itself is append only. So if you're interacting on different documents and all you're doing is appending, the writes are fast. But it's not designed to be an analytical database, which is where things like streams come in. So you can stream it out to Redshift, you can stream it out into Elasticsearch or Dynamo or another database to support any sort of analytic queries on top of that. But yeah, it's fully ACID compliant.
I definitely am on mute, Matt. Thank you. I was just saying, one last question from me. Where can people find your content and follow the stuff that you're releasing?
Oh, yeah, which is actually what I did, is I had a final slide, which I didn't show.
Actually, feel free to bring it back up.
Yeah, if you wouldn't mind. So these were just some useful links. So in the same way that we've seen people like Alex Debris create things like DynamoDB guide, I started building out a QLDB guide, the intention being it's a community effort. So that gives a bit more background on how to get started with some examples. And as part of that, I run the demo as a live site there. So you can go to demo.qldb guide, but if you go to QLDB guide, it's all signposted. We've got an organization on GitHub for the AWS South Wales user group. So there's a whole bunch of different repositories there that people are free to clone. So it shows how to stand up this sort of bicycle license domain using things like serverless framework, using things like SAM. It shows things like there's examples of if you have requirements, you need to run services within a VPC. How can you connect to QLDB using a VPC endpoint so that all traffic stays on the internal AWS backbone and doesn't transit and go over the internet? And then there's also this awesome QLDB repository, and that's where sort of try and create all the useful guides, demos, podcasts, videos. But all of these things I sort of see as community effort. So everyone is free to raise a pull request if they want to submit some data onto there.
Awesome, thanks, Matt. If you share those links as well, or you share the slides afterwards, it could be a good place for people to find them. Awesome. Well, that brings us on to our next talk. So I'm really excited to introduce Yann, co-founder of Koyeb. Yann, I'll let you take it from here.
Thank you, Ben. I will get started. So we will move from the data layer to the compute layer, and we will speak basically about Firecracker MicroVMs, which is a virtualization technology for containers and serverless workloads, actually built by AWS and which we are using at Koyeb. I'm the co-founder and CEO of Koyeb, and so to give you a bit of context, I spent the last decade building cloud service providers in Europe. So in 2011, it was Outscale. I managed the Scaleware, which is the cloud division of the Iliad Group, during 6 years. And since 2019, we are building Koyeb with my two co-founders. And basically, I'm probably going to spend the upcoming decade building cloud service providers. So it's pretty straightforward. If you're looking for me. And Koyeb is basically a developer-friendly serverless platform. And what we intend to do is to provide the fastest way to deploy applications globally. And we are trying to provide what we call the true serverless experience. And when we speak about serverless at Koyeb, we don't think only about functions, we also think about containers. We believe that serverless is really about having zero infrastructure to manage, and that the essential part is having this resiliency and scalability part, and that it should also come with fast continuous deployments, and that you shouldn't need to learn cloud provider specific things, and you shouldn't need to be trained to use this technology. So, and the business end game is to have faster time to market, and of course always sustainable engineering and cloud costs. So let's diving into Firecracker. As I mentioned, it's a virtualization technology, and it's a lightweight virtual machine monitor. Behind the scene, it's using Linux KVM to manage MicroVMs, and it's often confused with orchestrator. So it's definitely not an orchestrator. So it's not a drop-in replacement for Kubernetes at all. It's used by to power Lambda and Fargate at AWS. And it's really designed to secure container workloads or functions by increasing the container isolation. If we look a little bit back at the global container ecosystem and where it fits in, so you have the container as composed of three main things: the images, the runtimes, and the orchestrators. The images being Docker and driven by the Open Container Initiative. On the runtimes, the most famous one is Containerd. It's the standard one on Linux, which was open sourced by Containerd. You have Firecracker and gvisor, which was open source by Google and is used on GCP. On the orchestrator side, you have the most famous one, which is Kubernetes, and other ones which are not as popular, but OpenStack is also dealing with that, and Apache Mesos also. If we focus on the runtime and execution part, we need to look back at what it does, and it's actually virtualization. And you have like three main technologies and actually categories of technologies for virtualization. The first one is kernel level virtualization. So you have parallel virtualization and hardware-assisted virtualization. If you look at kernel level virtualization, the most popular example is Linux C groups. There used to be OpenVZ. It's still alive, but probably way less used than in the early 2010s. And in this case, you have the same guest kernel, and the security is kind of low by default. It's not built in. On the performance side, the overhead is really low because it's the same kernel, and you have fast boot times, and it's used by, for instance, Heroku to launch your applications. Then if you go to parallel virtualization and hardware-assisted virtualization, the most popular technologies are Xen and KVM. Xen was used by AWS on EC2 for probably like 10 years, and they switched to KVM. And KVM is really the industry standard. And the common thing with both of these technologies is that you have like longer boot times. It's usually in the tens of seconds, so 30, 40 seconds. But the security and the isolation is way better. And the overhead is higher than with kernel-based virtualization. And hardware-assisted virtualization is really the standard. I mean, if you go to AWS, GCP, or Linode or DigitalOcean, it's always on Scaleway. It's always going to be for the VM virtualization part, and EC2 like offers. It's always going to be hardware-assisted virtualization right now. And it matters for container runtimes because it's really mapped on these technologies. So the first solution to secure your containers is to use harder and C groups. So you'll be using SE Linux, seccomp, or AppArmor to build fine-grained policies and to filter all syscalls. Like you will be defining exactly which syscalls is allowed by your application. So if you go with a paravirtualized approach, you'll be using gvisor or Nabla, which are basically providing an application kernel. So it's a specialized kernel intercepting all system calls and deciding if they should be allowed and how they should be handled. And lastly, you have the Firecracker MicroVMs and all the technologies using hardware-assisted virtualization, which are usually using KVM. So the two most popular ones are Firecracker and Cloud Hypervisor, which are actually based on the same open source project, which is Rust VMM. And to give credit back, it was originally built by AWS took the technology from Chrome CrossVM, which is the hypervisor in Chrome OS. And in this case, you're really having the same kind of isolation with another kernel running on top of your operating system. And there has been also a bunch of other runtimes which are kind of dead or abandoned. If we focus on Firecracker, it's really designed for security and performance. They basically decide to remove everything which was unnecessary. So they, if you look at the standard for VM virtualization is QEMU KVM, and what they did is they stripped down all the unnecessary drivers, like a floppy driver, which you don't need, obviously, for your containers and serverless function workloads. And they did that basically to reduce, on one side, the memory footprint, and on the other side, to reduce the attack surface so that you have less code and less reduced risk of vulnerability. Another key point is that by reducing the footprint, they also managed to get the MicroVMs to start up in 125 milliseconds, which really matters when you're performing, when you're dealing with auto-scaling technologies and when you want to be able to deploy one container per function. On the integration part, they provide a RESTful API so that it's easier to configure, so it's pretty convenient. They, it also integrates everything to rate limit the network and these things. and you have full Linux support, so you don't have any issue. You can run any standard kernel, Linux kernel. It's also, and the last thing is that it's container friendly. So it's actually a separate project to run your OCI compatible containers inside of Firecracker MicroVMs, and it's called Firecracker Container D. It matters for you if you are basically operating the orchestration layer. If you need to deal with application isolation, you should look into this because it lets you avoid all system compromission. If the application is compromised, it's critical to avoid the attacker to gaining access to the hypervisor. And if you are a service provider executing untrusted code, which like if you're letting people upload small functions and you're executing them on behalf, on their behalf, you should pay attention to this. And if you look at the whole ecosystem and the progress of serverless, it's also really important, mainly because if you want to build a system where you have seamless scale to zero and auto scaling, you need to have fast boot times, and you need to have a technology letting you do that. If you're spawning functions and your MicroVM is taking 3 seconds to start, it's going to be an issue if you're splitting if at the end the function is only running for 200 milliseconds. And you, as a service provider, you're happy to increase density because it obviously also reduces cost. We already spoke about the security part, but it's really a key thing. To give you an example of how we use it at Koyeb, it's really the core of the platform, in the sense that if you deploy a function or a container on Koyeb, it's going to be running in MicroVMs on top of Perl servers, and these MicroVMs are Firecracker MicroVMs. So we use Nomad to perform the orchestration. We let you deploy Docker containers, and they will be running inside of Firecracker MicroVMs on top of Perl servers, which can be from any provider. The other component missing is the networking part. So if you have something similar to VPC and actually we are providing an even higher networking solution with a complete serverless mesh. On Discovery, we're using Kuma and Envoy, which are also open source technologies. If you look at it, so that's a vision of the stack, a simplified vision of the stack. We have the control plane, which is a Go API, and behind app.koyeb.com. Then we are calling Nomad to perform the deployment on the Perl servers, and on each Perl servers you have the hypervisor is Fedora Congress, and we are spawning Firecracker MicroVMs with a custom Nomad driver. And in this case, it's a Node.js application which is running, so it's packaged into a Docker container and running inside of the Firecracker MicroVM. So So inside of Koyeb, we basically deploy everything inside of Firecracker MicroVM. So if you're deploying a web app, a background worker, an event-driven function, or microservices on Conjure, they will all be running inside of Firecracker MicroVMs. So it's really a key thing into our platform. And that's it for me. Thank you very much. And if you have any question, I'm happy to answer them. You can give it a try at app.koyeb.com, and you can also join us on our Slack channel if you want to know more and give it a try. And it's basically going to be transparent for you.
Awesome. Well, thanks so much, Yann. I really enjoyed the talk. Really great to see it in action. If you have any questions, feel free to throw them into the chat and we can go through them. Sorry, guys, my connection just stopped there. Yes, if you have any questions, feel free to throw them into the chat. Really great to see the talk, Yann. Really interesting to see how it's powering your products.
Yeah.
Had you looked into Firecracker before you launched Koyeb, or did you launch Koyeb and then look deeply into Firecracker?
Actually, we started with Kubernetes. We started.
You can't say that word on this meetup yet.
Is it forbidden?
No, I'm joking.
Yeah, so we started building the serverless platform because as a service provider, we want to avoid you from using Kubernetes. We were looking at what would be working, and we used initially Kubernetes with gvisor, and we switched to Firecracker afterwards, simply because, yeah. So I mean, we are really strong believers that Firecracker is going to be the standard, or maybe a cloud hypervisor for political reasons, but just because Firecracker is supported by AWS, but it's the same technology behind it, and KVM has become the standard for VM, so we are strong believers that Firecracker is going to be the standard for serverless workloads. Sure.
And have you guys looked into any sort of edge workloads and what you're doing at Koyeb?
Yeah, so I mean, we've also been exploring like options like WASM,
sure.
But we were not convinced right now because in the sense that at this stage you're kind of limited. So I mean, it's really good for CDN providers where they want to run small workloads at the edge, but you tend to be limited because you don't have the flexibility to perform, like if you want to do machine learning, for instance, it's not going to work.
Sure.
So right now we don't see it like something which is. I mean, it's probably going to take a few years because it becomes mainstream.
Sure, makes sense. Well, if anyone does have any questions for you, Yann, I'm just going to add your screen share back to the screen. Can they contact you on that email address?
Yeah, definitely.
Perfect.
On Slack, we're happy to answer any question on how we use that.
Awesome. And is that your Twitter handle in the bottom left?
Is that what?
Is that your Twitter for Koyeb in the bottom left?
Yeah, right. It's Koyeb.
Perfect. Well, thanks so much for your time, Yann, and Matt, thanks so much for your talk as well. If anyone does have any questions, feel free to reach out directly to them. And if anyone wants to speak at one of the upcoming meetups, feel free to reach out. I'd just like to say thank you again to all of our speakers. Matt, I'll add you back into the share. And yeah, thank you so much. And thanks to our sponsors, Senza and Theodo, for making sure we can organize this. And hope to see everyone on next month's meetup.
Thank you, Ben. Thank you,
Awesome.
Matt.
Cheers. Thank you.
See you guys. Thank you. Bye.